Okay, good morning. My name's Michael Humphrey and I'm the Business Development Manager for Parker Aerospace. This is going to be a real mouthful. It is the Thermal Management Systems Group within the Gas Turbine Fuel Systems Division of the Aerospace Group within Parker Hannifin. That's the little tiny guy at the bottom of the food chain of a $13 billion company. So that's it, puts things in perspective. Okay, so, well, what I wanted to talk about was Parker's had a solution looking for a problem for well over a decade, and thank the Lord for VPX, because it's at long last given us a reason for being. So I thank VPX, I thank anybody who builds a 50-watt FPGA, anybody who builds a multiple processor core device that's only an inch square. Just keep doing it. I mean, this is really good stuff for us. So being part of a $13 billion company, you can't actually attend anything without the slide set going to corporate and them putting their mark on it. This is their mark. Okay, so Parker's involved in all of these markets. It's not a product presentation really, but this is how simple liquid cooling is. It's just a couple of cold plates that are part of a box. This is not rocket science. Basic format, ATR, AirInc 404, whatever, ATR formats, easy to do within the envelopes that we're given for regular conduction cooled environments. So standard core building blocks. Okay, this is the one I want to spend a little bit of time on. There isn't a trend here. It may only be less than 5% of the market, but there are a bunch of applications out there that are desperate to make use of all the power that you guys within the board level community are providing, okay? So yes, the air-cooled market's going to last for an awful long time. Air flow-by is giving people another lease of life. Boards of 150, 180 watts, not really a problem if you've got a fair amount of air and you've got air defenders big enough to protect you from the fan noise. But the bottom line is that liquid is here, and we are shipping into programs right now, not many, but we are shipping. So I wanted to show you some of these boxes. That top right, that's a very famous sort of three-letter curse there, Future Combat Systems. But 2005, that was the first, I think the first VPX box that was put in a statement of work for a big program. So that was the first VPX box that Parker actually built. Over on the top left is a liquid-cooled box, and underneath that graphic, you'll see one half of the box. So this is two back-to-back VPX backplanes, and there's, I think, 4 systems in here. You'll see the front is pretty obvious. You've got payload slots and a switch slot in there. So that's going in a very large UAV. There's only one program really that's coming up that's a large UAV for the Navy, but that's where that's going. Bags of I/O, and thinking of some of the earlier conversations about 3U and format and the way to get off the backplane. You can see all the I/O on these 38999s on this box, and with the high performance stuff that's coming off that backplane, those rigid flexes are, the answer to a maiden's prayer. That's about the only way you can do that. So Global Hawk, for those of you who've been around almost as long as I have, you're probably sick and tired of people telling you that Spraycore, which was actually a company that Parker purchased about 7 or 8 years ago, the spray guys were doing a great job, and those boxes are still on the U2 and on Global Hawk, okay? And it's a regular business of upgrades. It's the old story, somebody wants to change a board, upgrade the box, change the backplane. So this is an ongoing piece of business for us. Sprays around, two-phase cooling, just particular applications. Not going to set the world on fire, literally, but it'll do okay. Bottom right, what you've got there is a two-phase, that's a spray system, and that's on a large rotary platform. So spray in a really nasty shock and vibration environment, doing pretty well. So the one that I'd like to spend some time on is that fixed wing airborne puppy in the middle. That's what it looks like. It looks like your standard 8U 19-inch rack mount brick. That's what the guts looks like. So what's the problem here? Well, the problem is that every time you talk to a program manager about a system and you tell him he might need liquid, he has cardiac arrest because he doesn't have a liquid heat exchanger. He doesn't have liquid on his platform to provide you with a means of getting rid of the heat that you're developing in the box. So fundamentally, the challenge is I'm going to need a liquid-cooled system, but I can't provide you the heat rejection side of the coin. So in this particular case, we had to provide, or shall I say, the prime had to provide a solution where to the poor guys who were installing this unit had no plumbing. The program manager said, I cannot see any pipes anywhere. I don't have a heat exchanger. Oh, and by the way, I want to put this on 3 platforms: high altitude, medium altitude, and shipboard. So this is the culmination of a work with that prime to give him a 180R format. Those of you can pretty easily see the front to back situation for the ATR format. Top load, and the backplane in there comes from our friends at Elma. They did a great job on this high performance backplane for us. One side, on the lower, you'll see a whole bunch of hardware in there, and I'll show you another picture of that. That's actually the whole fluid management side. So there's a pump, an accumulator. Obviously, it's single phase cooling. I think this is PAO, I think. Is it? Yes, PAO. So this is PAO running around inside this box. And there's a smart pump controller in here, say accumulator. There's a bunch of valves and a bunch of sensors managing the flow rate, because the fans underneath are pulling air through the radiator, which is the heat exchanger. So this is a completely integrated chassis. It's liquid cooled, but there's no external loop. So this looks like an air-cooled box. So what we did was, as you see, there's the pump, the accumulator, and the controller on one side, and then there's the power supply on the other side. So let's go back to this. We're making those cold plates do double duty. They're actually working to take heat from the wedge locks on the side of those boards, but they're also providing a heat sink for, on one side, the pump controller module, the pump and all of the electronics on there, but on the other side, they're actually providing a heat sink for the power system, okay? One of the things that we've tried to do is separate the front end power, which is always the pain for a customer. When he starts changing around on the platform, he might go from 270 volt DC, he might go to an AC, it's single phase, it's 3-phase. It's always a pain in the rear end because you've got to obviously get the EMI right to match all of those different inputs. So don't put the burden onto the plugins, keep it outside that. So what we do is we have a modular system where we change all of the front end conditioning, I call it, down to a DC level. That's maybe 28, 48, 72, 68. There's about 3 flavors. And we pull that into the backplane, and then the backplane only has to do DC-DC, and we can probably pull a COTS power supply from one of the vendors that's got, knows much more about power supplies than we do, and give us a solution. So there's our integrated chassis. This is, I've said 3 kilowatts there. We're actually pushing, I think, 3,600 watts in this box at worst case scenario. So is that a standard product? Well, not really, but it's pretty close as a module. We've got all the elements right, and as I say, it's not rocket science, and the what Parker's really good at is fluid management, and this is the solution from us, from a mechanical fluid management side. This happens to be a system that is complete. So, the customer gets a fully integrated MIL XYZ shock and vibration EMI certified box. But we're quite happy to work all the way down to just the fluid level and work with a partner. So that's our 8U brick that's fully integrated. So, it's not quite the problem that the customer thinks it is if he doesn't have a liquid loop. Oh, and our power supply solution. This was that big system for the large UAV. This has got the back plane that drops down into the middle. And this has got a doghouse on the bottom. And the whole idea was all that power conditioning is in the base, and then we pull that DC rail up to the back plane underneath and let smaller, don't take up those valuable slots with too many plugins. 3U concept, so we're agnostic, don't care, whether it's VPX, VME, compact PCI. So very high density of 3U modules. And, having seen what you can now do on the fiber side and the RF side with 3U, I'll just maybe repeat what's already been said. 3U is moving like a train. I mean, a fast train. Fast train. It's moving pretty well. No, not quite. Not quite. So there's some really cheap and dirty ways you can do this. So I just wanted to show you this. We had a big headache with a customer. He said, you're not just giving me my box fast enough, and I got a load of software development I got to do. So I got to run my cars flat out. I need some liquid cooling here. I need some help. So our guys threw this together pretty quickly, and I just want to say that there's somebody once said to me, once you start using liquid, it doesn't matter how sophisticated you get within the box. Okay, once you've got liquid, it's a big help. So how you get that liquid through that cold plate, you can be fairly crude about it. So as you see, the side walls are manufactured with the same mechanical dimensions as the target, but all we did was embedded a serpentine pipe in the side and used some fairly heavy-duty connectors. The I/O panel is a direct copy of the target solution, and that's only weighs about 60 pounds. So it's it's a benchtop solution. So there are some very simple ways to use liquid and get the help. There's some premiums to be paid in weight and cost. They're not as big as you think, though. And more importantly, the benefit in terms of, I call it watts per square foot, is big. Not an order of magnitude, but my own gut number is 4 to 5 times is the benefit that you get in terms of as soon as you go from air to liquid, it's a 4 to 5 times benefit. There are other factors, but it's a big number.